Hello class. Today we're going to do our second video solving equations with variables on both sides. Okay, in this particular video though, there are going to be a few curveballs thrown at you. So we need to kind of look at some of the nuances that you can have when you have equations with variables on both sides. Again, why are we doing this? Because the state of Texas gives us a standard and it says that we need to model and solve one variable equations with variables on both sides of the equal sign. So we have to understand how to do all variations of that. So let's kind of review what we need to do in order to solve a problem like this. Well, the first thing I would do, I see a minus that I need to take care of. Okay, so I'm going to change that subtraction to addition, next number to its opposite. Now we know we have three basic steps that we need to follow in order to solve this equation. Step number one, get my letters on one side. Okay, that's our first step. So we typically like our letters to be over here on the left, so I'm going to move this 7x over to be with the 4x. And the way we do that is we add its opposite. So I'm going to write 7x plus 13. And now what do I need to add to this side to move that 7x? I need to add a negative 7x. Now, this is the thing that I'm going to add to the other side as well. What I need to add to one side of the equation, I need to add to the other side as well. So, over on the left-hand side, I'm going to write 4x plus negative 8 plus the new thing that I added on the other side, which is the negative 7x. Okay, now I combine like terms, put things together that are alike. So this 4x and this negative 7x I can put together to come up with a negative 3x plus, and I bring the negative 8 down with it. Now on the right-hand side, my x's should go away if we did everything correctly, and I end up with 13. Okay, so step number one accomplished. My letters are on one side. Now I need to move my numbers to the other side. So again, we do the same thing. We add the opposite. So I write negative 3x plus negative 8 plus its opposite, the positive 8, equals 13 plus the same thing that I added to the other side, the positive 8. So now we simplify, we do our math, and we end up with negative 3x is equal to, and now we take 13 and 8 and add that together, and we end up with 21. Now, our third step then is to solve. Our letters are together on the left, our numbers are together on the right. So how do I get rid of a multiply by negative 3? I do a divide by negative 3. And I end up with x equaling negative 7 for my answer. Now, that's how we solve just a regular equation with variables on both sides. So today what I want to look at is three new scenarios that you might encounter. Number one, 4x plus 6 equals x. Now you'll notice this one looks a little different from the previous problem. So if we go back to that one, you'll notice in this one we have a letter and a number on each side. In this one, we have a letter and a number, which looks normal, but on the right-hand side, I only have a letter. So out of the three steps that we do, get our letters together on one side, get our numbers together on the other side, one of those steps is already done for us. And you'll notice here that the 6, it's already together. There's only one number. So that means my numbers are already together on the left. So what I need to do then is instead of moving this x over to be with the 4x like we normally do, I need to move the 4x over to be with the x. And then my numbers will be on the left and my letters will be on the right. So in order to do that, 4x plus 6 plus the negative 4x, because that's what I add in order to move it, equals x plus negative 4x. So on the left-hand side, my letters do still go away, and I'm left with a 6 equals. Now we need to remember that if I have an x by itself, there is a 1 in front of it. We just don't see it, because how many x's are there? 1. So you don't really need the 1. To help us see it, we put the 1 there, and it helps us with our numbers. So I've got 1x plus negative 4x, which gives us negative 3x. And then how do I get rid of the multiply by negative 3? We do a divide by negative 3. We end up with x equaling negative 2 for our answer. Now we could take this negative 2 and plug it back in to check our answer. So 4 times negative 2 gives us negative 8, plus 6 gives us negative 2. Okay, so this value is negative 2, and then equals, and then we plug the x value in, and what is our x value? Negative 2, so yes, they do equal each other, so that makes this the correct answer. So that's one scenario that you might see. Okay, you might see not all the pieces there that are in a typical problem that we look at. Okay, so let's look at scenario number 2. Okay, so we end up with this one. 9w plus 3 is equal to 9w plus 7. Okay, so let's go through our solving process. Step number 1, let's get our letters together on one side. So I'm going to take this 9w and I'm going to move it over to the left-hand side. So I start with the 9w, so 9w plus 7 plus our negative 9w. That's what I add to this problem in order to move this 9w to the other side. So then I write 9w plus 3 plus negative 9w. Now you should kind of notice something happening in this particular problem. So when I simplify this left-hand side, I've got 9w and I've got a negative 9w. Those cancel each other out. They zero out, and we're just left with 3. Okay. Now, on the right-hand side, we look over here and we have a 9w and another negative 9w. And again, those zero out. And what are we left with then? We're left with 7. So our letters actually are eliminated. Okay, they go away on both sides of the equation, but then we end up with a statement that's 3 equals 7. Now what we need to understand is that statement is not true. So what's happening here? Well, what we need to know is if the variables in an equation are eliminated, they go away, and the resulting statement is false, then the equation has no solution. So what do we do when we have a situation like that? Well, one, yes, you do need to work it down until you have a statement like this. So you need to make sure that the letters do actually go away. And then there are 2 things that you do in order to finish out this problem. The first thing is we say that 3 does not equal 7. So we put a slash through the equal sign, and that slash means not. Okay, it was originally equal. We put a slash through it, so now it's not equal. And we write the phrase, no solution. Okay, and that's all we do. Okay, so if we run into a situation where our variables are eliminated and it makes a false statement, we cross out the equal sign and we write no solution. So that's the second thing that I needed you to understand about equations. Now, there is a third thing that we need to understand. Okay, and this one has 2 parts to it. Okay, one, if we see some things on one side that I could put together, we need to put those together. Okay, so before we try to start moving letters to one side and numbers to the other, if there's anything I can simplify and put together, do so. So like this 4 and this 3, I could put those together. And we end up with 5m plus, well, 3 plus 4 gives us 7 equals 5m plus 7. Now immediately, thanks to that last problem, you should know something's happening. Okay, so in this last problem, I had a 9w and a 9w. If these 2 letters are identical, my letters are going to go away. Okay, now if this were a negative 9w, then it's not. But because they are identical, my letters are going to cancel out. So in this problem right here, I hope you notice that my letters are going to cancel out, but you still need to solve it. Okay, we need to go through the motions with this line. So I'm going to write 5m plus negative 5m plus 7. So that's what I add in order to get rid of the 5m. So now on this side, I write 5m plus 7 plus the thing I added on the other side, which was negative 5m. So now my 5m's go away on the left, and I'm left with 7. My 5m's on the right go away, and I'm left with 7. So in this scenario, my letters are eliminated, but it doesn't make a false statement, it makes a true statement. So what do? Well, if the variables in an equation are eliminated, in other words, the letters go away, and the resulting statement is true, then the equation has a solution of all real numbers, which means I could plug in any number into this m, whether it be a rational number or an irrational number, and it would work. So what do I do in this particular case? Well, we write 7 equals 7, and then right underneath that we write all real numbers. And that's the answer to that question. So we've got 3 scenarios that I wanted us to go through today. One, sometimes we have some unusual circumstances where we don't have all the pieces. Okay, so we still go through the process of getting our letters on one side, getting our numbers on the other. It's just sometimes one of them may be done for you. And we add the opposite to do that. And then lastly, we still solve. Well, we will have a scenario where sometimes our letters will go away. They will be eliminated. And it will make a false statement. And if it makes a false statement, it doesn't matter what number I plug into W, it will never work. So this particular equation has no solution. And then the third scenario is where the letters do still get eliminated, but it makes a true statement. So if it makes a true statement, any number that I plug into the variable will be so. We'll make it true. So those are the three scenarios that we needed to look at today solving multi-step equations. Until next time.